behind groups of identities is to use the two fundamental identities that I introduced yesterday. All right? The two fundamental identities, tan theta is equal to sine theta over cosine of theta. Also, sine squared theta plus cos squared theta is equal to 1. Now be aware that the second identity can also be simplified, and you can write it as sine squared theta is equal to 1 minus cos squared theta. Also, cos squared theta is equal to 1 minus sine squared theta. Then you need your knowledge from algebra, factorization, simplifying algebraic expressions, knowledge of sets with regard to the conjugate. Okay? You need all that. So there is a whole range of concepts that you now need to integrate to answer these questions, including algebraic fractions. Some of the problems that you might have faced, they are algebraic in nature. It's from algebra. Because algebra is the backbone of understanding trig. If you understand your algebra very well, you won't have major problems in trig. All right. So we've got number 4. So number 4, as it is, the right-hand side is already simplified. Okay? So you have to simplify the left-hand side. To simplify the left-hand side until you get 1 over sine x, you might need a range of techniques there. Okay? So our left-hand side is equal to sine x over 1 plus cos x plus cos x over sine x. Alright? Now the first thing here, since you have got fractions, this is a fraction, that's a fraction there. The first thing which must come into your head, LCD. Okay? Now, here, as it is there, you have to find the LCD first. So the LCD will be the product of the denominator. Therefore, I have to multiply this numerator by sine x, this numerator by 1 plus cos x. Okay? So if I do that, I will get sine squared x plus, that will be plus 1. Okay, in this case, it's going to be cos x plus cos x squared. Okay, so it's going to be cos squared x. I can write it as cos squared x plus cos x. This is all over the LCD. Now, the LCD is the product of these two. So I can write it as sine x times 1 plus cos x. Alright? Now, I'm sure you can see that there's sine squared x, there's a plus here, there's a cos squared x. That is equal to what? 1. Alright? It's equal to 1. So this becomes 1 plus cos x all over sine x times 1 plus cos x. I hope you are following that. So the numerator, it's a binomial. The denominator has got a binomial which looks like the numerator. Therefore, that numerator and this can cancel out. If we go back to the basics, okay, we go back to the basics, we can split this up this way. We can write it like this. I think I'll just show you. So we can write this as 1 plus cos x over sine x, right, times 1 over 1 plus cos x. You can write it like that. Okay? Then this and that will cancel out because of multiplication. So you end up coming to 1 over sine x. You have to know your algebra. Okay? So the left hand side is now equal to the what? The right hand side. Okay? Yes.
So I did it very, 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 very differently. And I don't really understand what you did. Going from, like, where did the sine squared x and the cos squared x go?
Okay. You see, what I wrote there?
Yes.
The
Oh,
fundamental
it's
identity.
Okay.
Yeah, sine squared x plus cos squared x is
Okay,
equal to 1.
yeah, okay. Sorry, I didn't see that. Is it okay if I use, like, conjugates to get this back? I don't know.
Now you see, it is possible.
I did.
It's number what? Number 4. Yeah, it's correct. We used conjugates. That's fine. Alright, so Sean used, listen, he used the conjugate of the denominator. Right? Hey, can you pay attention? Pay attention. Do you know that if I'm standing in front of you, I can tell you who is not paying attention, who is not. Don't be physically, don't be physically be here. Be both physically and mentally be here. Right? So he used the conjugate of this denominator. Right? So he multiplied sine x by 1 minus cos x. He multiplied this denominator by its conjugate. Then he simplified this part. Right? If you simplify it, you can try it on your own during your own time. If you simplify it, it will come out. You come to 1 over sine x. That's the one over the second. Which second? No. There is no need to use the conjugate for the second term. You can use the conjugate for the first term. It will come out. Because you get to a point where you have the same denominator as sine x there. And then you just simplify the numerators, you come to 1 over sine x. Yeah, you must go home and try it out. We cannot talk about, alright, I cannot write all the solutions. He shared how he got it. So you must go home and say, but Sean did it using the conjugate, let me see how he did it, then you try it out. That's how you learn. You can't just observe. Maths is not about observing. Please be aware. It's a practical subject. You have to do the maths. Don't be a spectator. Okay? So you must go home and sit down. During your own time, you sit down, you try using the conjugate. Okay. Let me come on. So I've done that. Then number 4. Sorry, number 6. So number 6, we have got 6 tan theta over cos theta is equal to 3 over 1 minus sine theta minus 3 over 1 plus sine theta. Okay, I'm gonna be honest with you. This question looks very scary. Okay, because probably it's long, you've got binomials as your denominator, but it's not difficult. You can simplify the right hand side. It's much better here to simplify the right hand side. Okay? Find the LCD. Okay, so let's do it. So the right hand side, right? I can find the LCD. It is the product of these two. And can I have your attention at the back? By now you should know that if you multiply 1 minus sine theta by 1 plus sine theta, you get a difference of 2 squares. You don't have to stress yourself trying to use FOIL and all that. You should know that, okay, 1 minus sine theta times 1 plus sine theta gives me a difference of 2 squares. It should become natural that when you see it, you know that, okay, the difference of 2 squares. So multiply this by that. And so you get 3 plus 3 sine theta. Okay? Then, are you following?
Yes.
Yeah, I'm using the LCD. The LCD is the product of these two. Therefore, I have to multiply this 3 by that denominator, this denominator by that minus 3. Okay, be very careful of this minus 3. So I'll write it as minus 3, right? Then you end up having a plus. Okay, the plus here, so it will be plus 3 sine theta. Plus, so that's minus 3 plus 3 sine of theta. This is all over. Now your denominator becomes 1 minus sine squared theta. Okay? Don't be scared because you saw a long expression. Okay? Don't be scared. Just know your basics. So from here, 3 minus 3 will give us a 0. And then 3 sine theta plus 3 sine theta will give us a 6 sine theta. Okay? If you practice a lot this type of question, you should be able to see that this 6 here, this 6, this one here, that 6 there, because there is tan in the numerator there, it means you must have sine on top, and there must be a 6 somewhere. So that 6 sine theta which I got is a clue that I'm on track because of this 6 here. And the sign here is an indicator that somehow I need to have a cos as my denominator. You must use common sense when you are doing it. Then here, convert this 1 minus sine squared theta. If you want to create tan, the only way is to convert the 1 minus sine squared theta to cos squared theta. It becomes simple now. Okay? What do we have there? Check, we have got a cos theta in the denominator. The good thing is, I can break this up and write it as 6 sine theta divided by cos theta times 1 over cos theta. You have to know your algebra. Not only just on the surface, deep. Okay? Then this becomes 6 tan theta over cosine of theta. And this is the what? This will be the left-hand side. Okay. Okay, so your left-hand side is equal to the right-hand side. Yes.
So from your second step where you get cos squared theta, couldn't you just break cos theta up and cancel out with and then use tan and then use the tan equal sign of the cos?
Yeah, that's what I did.
Yeah, but you didn't have to break it into two, did you?
Okay. The reason why I broke it into because I'm a teacher. If I was writing a test on my own, I was not going to write this step.
Oh, okay.
Yeah. Because someone was going to ask her, how did you get the tan when the denominator is cos squared theta? That's why I had to break it up into 6 sine theta over cos theta, so that at least everybody in the class, even though there are some people who don't pay attention, take medication if you've got issues. Right? That's where the tan comes from. Then that's 1 over cos theta multiplying the 6 tan theta.
If I got the right answer, but once again I used conjugates, it is fine.
Yeah, it's fine. As long as you are thinking, because it is possible that the question can be done in more than one way. So if you use the correct mathematical concepts and your argument makes sense, then you deserve your full mark. Alright? Okay. Any question? Yes. The what? Yes. They can never be unequal. It's an equation, so there is equality. The only thing is that you are being asked to prove that the left-hand side is equal to the right-hand side. but they are equal. So it's like show us that the left hand side is equal to the what? Is indeed equal to the right hand side. Alright, I also want you to be aware that this, can I have your attention? We could also do the left hand side. Right? So we can break it up, but when you break it up, you need to be aware that you might have to write this as 3 tan theta plus 3 tan theta. Because we have got this 3 here and that 3. Okay? You can try, I'm not going to do that because of time, but this can be done there. Right? Okay, number 8. Number 8 is very simple. Number 8,
Okay.
each, obviously you have to convert the tan to sine over cos first. Okay, so the left hand side is much better to simplify, but it can also be simplified from the right hand side. Okay, so those of you who had issues, okay, who had issues, I'm going to do it from either side. Okay, so let's start with the left hand side first. So our left hand side, first we convert the tan to sine over cos. If you have challenges in number 8, because a number of you have got issues there, make sure you pay attention. So you can write this as 1 over cos theta minus sine theta over cos theta. In a test, you get 1 mark for knowing that that time is equal to sine over cos. So this is how I'm going to start. Right? Then, don't do anything yet. Determine your LCD. That's what? Cos theta. Okay, so let's carry on. So we can write it as 1 minus sine theta over cos theta. This is squared. Right? All I've done here, I've simplified what's inside the brackets. Okay? How to break fractions? Common denominator. Therefore, I can subtract the sine theta from 1. So I write it as 1 minus sine theta over cos theta all squared. And I got that. Okay. I didn't do anything which is complicated. Then the next thing, this is an indicator that I've got 2 terms. Okay, both of them are the same what? Denominator. So we can just say 1 minus sine theta over cosine of theta times 1 minus sine theta over cosine of theta. Okay? For the numerators, they are binomials, so use FOIL there. If you use FOIL there, you get 1, then you get minus 2 sine theta, okay, plus sine squared theta. This is all over cos squared theta. Okay, but before I do this, I think I need to, maybe I might simplify it further. Let me check again my left hand side. Okay, I've got 1 minus sine theta, so there was no need for me to remove brackets there. Okay, we must use common sense. Are you following? Yeah, there is no need to use FOIL in the numerator there. Because if you do that, you can end up simplifying it too much and you can get stuck forever. So you need to be very careful. So since I've got 1 minus sine theta on the right hand side as the numerator, what that means is that instead I can just multiply the cos theta and the cos theta, but I should not touch the what? The numerator. So I can write that as 1 minus sine theta squared. This will be over cos squared theta. So all I've done is just multiply the denominators. I know that this cos squared theta is equal to 1 minus sine squared theta. So I can then write this as 1 minus sine theta squared all over 1 minus sine squared theta. Now I'm smiling because this is a difference of 2 squares and it can be factorized. So if I factorize the denominator, I'll get 1 minus sine theta squared over 1 minus sine theta times 1 plus sine theta. Now I'm happy. So one of these two, you cancel with that. And then you'll be left with 1 minus sine theta over 1 plus sine theta. And then, so that means our left-hand side is equal to the right-hand side. Okay, so we have simplified the left-hand side. Let's do it from the right, because the question can also be done from the right. Do you have any questions? Huh? Do you have any questions? Okay, so let's now simplify from here, from 1 minus sine theta until we get that left-hand side. Okay, so this is method 1. So method 2, we'll do it from the other side. Okay, so our right-hand side is equal to 1 minus sine theta over 1 plus sine theta. Okay, now you must use common sense here. If I want to have this tan here, obviously it means that the denominator, before it was tan, it was sine over what? Over cos, right? And to create a cos, and have a cos here, means I need to manipulate that denominator, right? So, well, I would suggest that we
He's buffering.
okay, let's multiply by the conjugate. Okay, let's multiply this by the conjugate of the denominator. So that would be that over 1 minus sine theta. Right? Okay, you following that? Right? Then, so if you multiply this and that, well, I'm not going to rush to simplify. So what I'm going to do is I'll just say 1 minus sine theta squared at this stage. This is all over. Then this 1 plus sine theta, I can multiply it with that, and I'll get 1 minus sine squared theta. Okay? You're following that? Yes. I'm smiling already. Then this will be equal to 1 minus sine theta squared over cos squared theta. Okay? I know you, hey, can you pay attention? You might be wondering, how are you going to get tan from there? We can get tan. So let me move on to the next page. Let me move on to the next page. Okay, before I carry on, please be aware that we have got a 1 over cos theta, and here we've got minus tan theta, but this tan theta is the same as sine over what? Over cos. So in the end, I need to have the same denominator there. So I can then write it as, okay, I'm here. Let me move on to the next page so that I don't overcrowd the work there. So I can split this up and write it as 1 minus sine theta over cos theta times another 1 minus sine theta over cos theta. You have to know your algebra there. If you want, you can put brackets there, but I'll put the dot, or maybe I'll just put multiplication sign. Are you following? Is it making sense? Right? Then, since we have a common denominator, I can rewrite it as 1 over cos theta minus sine theta over cos theta. Now I'm happy now because the tan will come from there. So I can put this in brackets. Then times, there I'll do the same, 1 over cos theta minus sine theta over cos theta. Now I'm sure you can see that they are identical, the two binomials. Okay, this is equal to tan, so I can write this 1 over cos theta minus tan theta. Right? This is also equal to tan theta and it's identical to that binomial. So I can put my square. Okay? Are you following there? Sfundo, you're okay? Okay, so this is our what? What was it? Right hand side. So the right hand side is equal to, okay, let's just write this. Right hand side is equal to the left hand side. Okay? Alright, so I use the concept of the conjugate and knowledge of algebraic expressions. Okay, and also the fundamental identities. Alright?